Okay, so this is basically pp chain reaction. Why pp? Because one proton fusing with another proton through a chains of reaction. We have to, what is our aim? Our aim is to study the formation of helium from hydrogen. Hydrogen means single proton, right now. I am not considering any electrons, bare nucleus. So single proton, if I have to make a helium, then I have to fuse 4 hydrogen nuclei together. Now if you go into the row, you will see most of the time the accidents are 2 body type. Okay, and if you do a study, then maybe you will observe that in the last 10 years there was one accident which was where 4 vehicles were involved, or 1 person and 3 vehicles. Okay, and compare it to the number of 3 body accidents. Maybe in the last 10 years there were 20 or so. And what is the number of 2 body reactions, 2 body collisions? Maybe lakhs, something like that. So the statistics goes down. The possibility of collision of many body particles, right? And here we are talking about the fusion reaction inside the sun, where the density is not very high. Okay, classical regime. Number 2, we are still talking about non-relativistic scenario. So the gas is classical and non-relativistic. Okay. So under these situations, the most possible way of producing the energy that we are seeing outside the sunlight is through PP chain reactions. That means 4 proton will fuse, but through a chain reactions, cycle of reactions. So let's start our study. So here you see the first is 1 proton fusing with another proton and forming 2 hydrogen. The rest is also there. Now this will again fuse with another proton, and as a result we will get this 3 helium. Okay, now starts the bifurcation. This 3 helium has 2 paths. You see, there are 2 possible paths. In one path, the first inside the sun, if you think about that, just think that a fusion has just started in a star, not about the sun. Just think about some star where the fusion has just started. So the first this step will happen at that time. That means PP1 chain. This is the PP1. This entire set is PP1 chain reaction. Okay, this entire set. So what will happen is that after the formation of 3 helium, this process will continue. What will continue? This process. And it will continue up to what time? Up to the moment where there is substantial number of 3 helium. The population of 3 helium nuclei increases. Then what will happen? 2 and 3 helium will fuse together like this reaction, and then a 4 helium nucleus will produce. Okay, now this is the very first step, and this is the PP1 chain reaction. Next is after some period of time where PP1 chain reaction has been occurring, then inside that star there will be substantial population of 4 helium which are produced by PP1 chain reaction, right? Now the second case, this bifurcation, the second part happens. Now this 4 helium will fuse with the existing population of 3 helium, and then a new step will start, this formation of 7 beryllium. From this 7 beryllium there will be another 2 possible paths. You see, one is 7 beryllium capturing electron forming 7 lithium, and then 7 lithium again fusing with an hydrogen, ultimately forming 4 helium plus 4 helium. So This is the set of reactions known as PP2 chain reaction. Remember, first when there is nothing, only hydrogen, then only PP1 will happen. Slowly, after a substantial period of time, the abundance of inside the star will change, because now along with one hydrogen there is 2 hydrogen, 3 helium, and then 4 helium. These are the results of PP1 chain reaction. Okay, then PP2 will start. Now what are the, if I ask you what nuclei are produced during this chain reaction, you can easily see 2 helium, 3 helium, then 4 helium formed through PP1, then 7 beryllium, 7 lithium, and ultimately 4 helium. Okay, now there is yet another path, and this happens after again a substantial period of time. This corresponds to the PP3 chain reactions. This is a little bit lengthy. So here you see the same 7 beryllium is utilized, but here instead of capturing electron, this reacts with existing proton, forming 8 boron, and 8 boron decays very fast, forming 8 beryllium. Again 8 beryllium decays to the 2 helium nuclei. Now just a second, the Q value for each of these reactions is somewhat different. Okay, now the net reaction I am shown over here is this reaction. Okay, continue. Which one?
3 helium plus 1 each.
3 helium plus
hydrogen.
Now this entire thing, I am not showing you the masses of the nuclei. You have to consider, the calculating the Q value, this has all been taken into account over here. Because in that way there will be even many more possibilities, right? See here, it is capturing electron. I can even fuse this thing over here and try to do many. You can do this exercise yourself, but ultimately this is the thing which has been established because of the Q value factors. I am not showing the masses. If you consider the masses, then you will see that okay, this is how the entire thing flows. Okay, the most important thing is that PP1, PP3, it happens at the last stage, because for this formation you need 7 beryllium must. Okay, and one very important thing is, when does this PP chain reaction happens? When the temperature is between 5 and 15 into 10 to the power 6 Kelvin. Okay, the temperature dependent thing as well. If the temperature is higher, then another set of reactions will happen. CNO cycle.